is Diana Seville. Thank you. I'm the co-founder and president of BrainMind. For those of you new to the community, BrainMind is an ecosystem of brilliant and talented scientists, creatives, entrepreneurs, investors, and philanthropists. And actually, quite a few more artists have joined our community because of this event today. So our mission is to bring the most impactful ideas in brain science to wider populations. And we particularly focus on underinvested ideas, ideas that could bring incredible benefits to humanity that may currently be overlooked by funding structures. And we host meetings to showcase those ideas, bring people together like you to help to scale them to help as many people as possible. So advisors in our community have helped us to determine our focus areas. We're a small group. We can't determine what the most impactful neuroscience is, but we've brought together heads of departments at top universities, architects behind the US Brain Initiative, folks leading in industry, many of you are here in this room, to identify which are some of the most important spaces. And most recently, our journey has led us to neuroarts. And more specifically, Susan Mang-Salmon led us to this when she wrote a beautiful paper in 2019 that really declared the field of neuroaesthetics and pointed to a mounting body of evidence that aesthetic experiences could make a significant difference for public health, for individual health, for societal health. And then Susan and Ivy together wrote a beautiful book, Your Brain on Art, which you can collect a copy at the back of the room. And they brought that message to the next level, really bringing public understanding to this phenomenon that we all know on some level is true, that this truth that the arts are beneficial. And so I asked Susan and Ivy to curate this entire day for you. And who are you? You are here today because either you are revealing the truth of art's benefit through scientific inquiry, or you are living that truth through being an arts practitioner, or you are acting on that truth as an entrepreneur or investor or philanthropist to bring the benefits of arts to more people in the world. So we have a day packed with gorgeous experiences. I hope some of you have dipped your toes into the experience pool. Who did a passport activity last night? And I'd be remiss if I didn't acknowledge, by the way, the Lori Tisch Illumination Fund and Rick Luftglass for making so many of the arts experiences possible. A few quick guidelines to make the most of your experience today. The first is use the brochure, check it out. It'll help give you some context, help you determine where you want to be, what you want to experience. The second is really make an effort to meet people from completely different fields. That is the magic of BrainMind, that you have scientists, entrepreneurs, investors, all these different groups of people. You should really make an effort to meet folks outside of your domain. That's where the magic happens. The third is talk to our brilliant volunteers. These are postdocs, PhD students. The undergrads that are here beat out hundreds of other applicants to be here. So please strike up a conversation with them. They're absolutely brilliant and they're wonderful. Thank you to the volunteers. Generally, actually I'll just pause here. The culture here at these meetings is just to think about not what the meeting can offer you. We're not here for edutainment. We're here with an orientation to our specific expertise and networks and capabilities to offer something up to the community. So really frame your mindset in that way. What is it that you can offer to help to build these ideas, to help bolster the people in this room? What is it that you have to give? And then finally, I just want to remind you to pace yourself. We have a lot of content today. Go upstairs and get a breath of fresh air in the outside. We have an hour-and-a-half long lunch. Use that to decompress and have deeper conversations. And with that, I just want to make sure you take time to enjoy the space. And I want to welcome Ivy Ross to the stage.
Thank you, Diana. I'm Ivy, and it's a pleasure for Susan and I to be here to bring our book to life. So we believe that we're standing on the verge of a cultural shift in which the arts can deliver potent, accessible, proven health and well-being solutions to billions of people. This is an audacious goal, but one that is within our reach, especially with everyone in this group today. So published last year, our goal was to bring the science of the arts to the general public, as Diana mentioned. We interviewed over 120 people in all walks of life, from scientists to art practitioners and people with lived experiences, and then wove those stories and science together with personal stories. And after the book launched, we heard from thousands of individuals that the book actually validated what they knew intuitively and put into words what they had felt. And most importantly, people told us that it gave them permission to make art again. Who knew that they were waiting for us to tell them that? And then the book became a New York Times bestseller in just 6 days after our publisher said that, I remember our publisher said, well, ladies, a book with the word art never makes the New York Times bestseller list. And we said, well, man, we're not doing this to get on the bestseller list. We're doing it to get really valuable information out in the world. And then as Susan and I were running to catch a plane, he says, oh my God, call me, with a big circle. It made the list. So it was the right way for that to happen. But one of the best awards last year that we got was the most shared book, which meant that people were passing it along and sharing it with each other. That meant a lot to us. And also that it's being used now as a guide and curriculum in schools, policy, and much more. So I believe Your Brain on Art has been so successful because the world is hungry for better solutions, as much of what we're doing is not working. And we now know that we are wired for art. So the arts are already being deployed in literally every sector of society, and the momentum is accelerating. Rigorous research, and some of you are part of this, is rapidly expanding through public and private sector. Some examples: Francis Collins, former head of NIH, has championed this work at a federal level, investing $35 million over the last 5 years in music research alone, and that investment resulted in an NIH toolkit for researchers to ensure rigor, including protocol guidelines, new biometric tools and techniques, and agreed upon outcome measurements for music. So this work is forming a baseline for other art forms. If we can get all art forms to go through this kind of process, we think it would be terrific. And the good news is we're finding out that making and beholding the arts are independent of income, age, and ability. And one of the most extraordinary findings is that you don't have to be talented or good at the arts to have a significant impact. So I love this graphic. It's a data visualization of many of the art modalities that we're talking about that allow for creative expression. You know, Susan and I went back and forth about, when you say arts, you know, what arts? And we really came to the conclusion that it's the things that allow you to creatively express, because we've got so much that is repressed and we need to express. And more arts are being created every day through the use of technology. So when we look at this image, we see a pantry of ingredients, almost like a new periodic table of combinations and possibilities as we together shepherd humanity into the next version of our civilization. And now I'd like to pass it to Susan.
Okay, so I never do this, but I'm going to do it today. I'm going to take your picture. And here's why. Because you are the people that are going to leave this room, and you're going to make the world a better place through the arts. And I want to take this picture now so that I can say, this is where it started. So, all right, I don't know how we're going to do it, but let me try. Hold on. Okay, Okay, so here's what you need to know. I have 5 minutes on the stage. I just wasted 3. You'll be getting copies of this new panorama. So thank you, thank you, thank you. It is thrilling to be here, absolutely thrilling. Let me see if I can make this work. Okay, you can see my technology skills are so good. So who's the hacker back there? Keith, please stand there. So I know I should have been a comedian. So we're going to learn a lot today about the way that the arts change your brain and body, and that's incredibly exciting. But as I said, and Ivy has shared, and Diana has really voiced, this is about a call to action. And I think we need to really think about the fact that this work is not something that can wait 20 years. It can't wait 15 years. It can't wait 10 years. It is shovel ready, and why we certainly need to know more about the neurophysiology of the arts. We have the knowledge right now to start to deploy this in incredible ways. And there are things that are missing for sustainability, and we'll talk about a lot of that today. But just as level set, neuroaesthetics is the study of how the arts and aesthetic experiences measurably change your brain and body, and how this information can be translated and used in practices in health, well-being, learning, community building, and flourishing. You know, we all don't want to just survive. We don't want to cope. We want to thrive. And I think this work gives us that opportunity to really do that, because at the heart of the arts are joy and well-being and meaning and purpose. And I think that's really why we're here on this earth. So philosophers and artists and children have always known the value of the arts, and it's really only been in the last 25 years that you scientists are really catching up with the artists. So thank you. Thank you, scientists, for catching up. There's a lot to learn from each other. Science and neuroscience is really important. Neurology, cognitive science, psychiatry, all of these disciplines are fantastic. But the truth of the matter is there are many ways of knowing. And throughout the day, you're going to hear many of them through people with lived experiences, through indigenous culture, through the ways that we think about economics, and also through the way that academics work, and certainly from the artists themselves. So let's see if I can do this. Oops. Uh-oh, there we go. So I just want to level set a little bit about the arts. You know, through the work that's been happening at the NIH and the NEA, what we now know is that the arts affect simultaneously a complex system of neurobiological and physical systems like nothing else. So the arts are true neuromodulators, and we know that while we're looking at neural systems and cognition, we're also looking at respiratory systems, and we're looking at muscular system and cardiovascular systems that are simultaneously engaged as we are engaged in different art forms. And that's an enormous opportunity to be able to leverage this for many different kinds of health and well-being. But the only way that the arts can get into our bodies is through our senses. And so I wanted to just give you a couple of fun facts before we move into our first panel. And that is that in an hour, you will process 34,000 pieces of visual information. In your fingers, you have over 3,000 touch receptors. And in your body, you have over 4 million touch receptors. And they are constantly informing your body and activating neurotransmitters. Your nose has 1 trillion different odors that it can detect with over 400 types of scent receptors. And your nose turns over those receptors every 30 to 60 days. So, you know, I think we sometimes forget in such a transactional world that we are organisms that are constantly changing to be able to bring in the changing world. And it's extraordinary. Your body also processes sound in just 3 milliseconds. And researchers are now discovering that we don't have 5 senses. We probably have dozens of senses that are really being activated to understand all of these different perceptions and sensations that are happening in our bodies. So this is an image by Greg Dunn, who is a neuroscientist and also a visual artist. And what I love about this piece is that it it really represents the complexity, but also the integration of all these incredible sensory systems, but also processing systems that from the limbic system to the prefrontal cortex, the parietal globe, the temporal globe, and to really be able to start to understand things like saliency, which you'll hear a lot about today, about the way that we're actually to have all of these different systems activate at the same time. You know, it's not just our brains, but our bodies take in all of this information, yet we're only aware of about 5% of the sensory information that comes into our bodies. And so there's an incredible opportunity to be able to process this information for all of these moments in our lives. So we're going to share a lot about sensory systems throughout the day, but Ivy and I are really do-think people. We like to do stuff, and then we think about it. So we're going to ask you to also be do-think people today, and this is a highly, highly immersive day. So you're going to be up on your feet. You're going to be moving around. We're really excited about all the things that happen. Jill Bolte-Taylor is a neuroanatomist who coined this quote that we love, which is, "We think of ourselves as thinking creatures that feel, but we're actually feeling creatures that think." And when you think about that, it's pretty amazing. So and our first session is called The Anatomy of the Arts, and that is going to be chaired by John Ngai, who is the head of the Brain Initiative at NIH. And his group's goal is to really start to level set some of the science, some of the basic science around the neuroarts to really be able to help us think about how this changes throughout the day. But I'm extremely excited to welcome to the stage Renee Fleming, who is the world-renowned soprano and also arts advocate around the world for neuroarts. And last night, Renee finished the run of The Hours, which is one of the most extraordinary plays. And I'm so honored for her to be here. She may not be able to talk, but she can sing. So, and then David Leventhal from Mark Morris Dance Company, who runs Dance for PD, is also going to open up some breathing and some movement exercises for us. So let's get started. Thank you.
Thank you, Susan. Thank you, Susan. And what a fabulous introduction. And I also want to start with, let's think about being in our bodies and feeling and finding as many places as we can to feel. We're going to start with breath. So the foundation of my art form, because it's centuries old, 5 centuries old actually, and it's based on best practices over all of that time, which science now supports. So that's the science of singing, the science of physiology, and the science of breathing. And the foundation of what we do is all breath. Breath, breathing, breath support, breath control. So let's just have, first of all, start with just rolling your shoulders. Rolling your shoulders. If some of you didn't sleep very much like I didn't last night, you're going to want to kind of wake everything up. And then side to side with the head roll, the other side, and down, not back. Fantastic. Now for breathing, what we have to do, because we don't, it's automatic. We never think about breath. It just happens, right? But we're underutilizing this incredible power that we have to either utilize breath for calming down, for getting excited, for actually helping with nerves. If you're public speaking, taking long, slow breaths before you get on stage can make a huge difference. But let's just start with thinking about breath capacity. So we have all this training for years. The diaphragm is the largest, almost the largest muscle in the body. I think second largest muscle in the body, which is from the sternum to the spine, and it lowers by about 6 centimeters in order for our lungs to fill with air. And we breathe very shallowly for the most part, but let's try to take a very deep breath. So bend over slightly. Put your hands on your rib cage, because your rib cage, especially the bottom 3 ribs, can significantly expand when you take in a breath, but feel expansion also in your back. So just take a deep breath. Go ahead. In. Hold it for 3 seconds, 2, 3, and out. So, and then also think about releasing the abdominal wall, because that's going to enable you to have more expansion. So one more time, in, 1, 2, 3, full expansion. Don't raise your shoulders holding it. Relax your shoulders, and out. Great. So now let's just do for counts. And then David is going to come up and add movement to this. All right, we're going to count to 6, inhaling slowly. I would purse your lips on the way in, because it creates a little bit of resistance, so you can slow down that process. Here we go. 1, 2, wait, sorry. Big breath first. Ready? Inhale. And exhale. 1, 2, 3, 4, 5, 6. And last time, inhale. Full expansion all the way around, including your sternum. Allow that to raise slightly. Hold. And exhale. Now shake it out. Shake it out. Get everything kind of... we have to do a lot of warming up that helps us make sure that we're fully connected to the entire body. So David is going to come in. David, introduce yourself.
Hi, everybody. Good morning. I'm David Leventhal. I'm a dancer, a dance educator, teaching artist. For the last 23 years, I've been teaching and working with people living with Parkinson's and other movement disorders and welcoming them to this wonderful world of dance and movement and music. So thank you for the introduction. Dance really is also based on breath. And what we do is we combine this sense of breath with music and expression and also collaboration. So we're going to do just a few moments of moving together using Renee's beautiful breath sense together, and just stay tuned for more ideas here. So what I'd like you to start doing is thinking about the breath we just had, but see how it can start to inhabit your physical body beyond your ribs, beyond your lungs, beyond your diaphragm. Let it start to grow into your arms, your hands, your face, so that our body, our full body, is actually the amplification of breath, the physical expression of breath. And we can start right in with music. Thank you. So I'm not going to tell you how to move, but I want you to really be attuned to your breath and think about amplifying the natural movement you have when you breathe into a larger expression. You can think about an accordion or a bellows, anything that takes in air and starts to fill the space around it. So we think that our space is defined by our current position, but it's not. We can actually move our bodies and our minds out into that space.
You could stand up if you want to.
Yeah, you're welcome to stand, move around. I'm going to invite you to think about the breath maybe in your hands. So how might the waves of breath start to fill your hands, your fingers? Maybe you're intersecting with somebody next to you. And thinking about now the idea of having paint on your fingers. And you're actually starting to paint the space around you. Painting the ceiling, painting the floor. You can even paint your own body, perhaps the furniture. Thinking about the colors you would like to create around you. Is it an orange paint, a red, a dark blue? And maybe thinking about little dots of color. Georges Seurat, little points of light, points of color all around you. Think about somewhere you haven't looked yet today. Open your brain up to that point. And maybe even splattering that paint out. Again, any speed, but think about flinging that paint out, sort of Jackson Pollock style, Just splatter the room. Throw it out as far as you can. Throw it to the person in front of you. Yeah, beautiful. And start to just calm that down, feeling all of the energy in the room. Taking a deep breath. And we're going to start to rise together now that we've had our own experience. We're going to start to float up, thinking about your arms perhaps as wings, finding the height, whatever's comfortable for you, and the same generosity of time that you had going up, you're going to have coming down. Now we're going to do that same movement. We're going to start over here on this side. So you're going to start, think about a stadium wave, and we're going to pass that movement across the room. Oh, beautiful. And let's start on this side now. You're going to start, and it's going to pass across. So we have to look at our partners next to us and figure out when to go. Beautiful. Yeah, let's try that now all together one more time. All the way up. Indulge in this music and indulge in the time that you have. Finding the suspension at the top and floating down. Like you're floating on a cloud. Breathing fully throughout. Again, starting on this side of the room, sending the energy all the way across. Beautiful. Good. And now our friends over here, you're going to start, and you're going to send it back. It's going to ripple across like a wave. All right. We're going to up the ante a little bit. We're going to start in the front row, and it's going to pass back. So front row, next row. You can see it coming to you and catching it. Yeah. Beautiful. Can we try that one more time? First row. Next row, keeping that flow going. All right, now we're going to do something really challenging. You're going to have to use your other 11 senses. So we're going to start in the back row. Sense that movement behind you. Yeah. Beautiful. How did you do that? Nobody even looked. That's amazing. Let's try one more time. That was an experiment. I didn't know it was going to work. Back row.
Our brain waves are synchronized
Beautiful,
now.
totally,
Yes.
yeah. Everybody together. Thinking about all the colors you created in your painting, your dots, your splatters, your lines, and just sign your work of art. Your own beautiful big signature, and send that signature up to the world.
Yeah.
Thank you. That was beautiful.
Bravo.
Yeah.
Bravo. I want to say, so next time we do this, we'll have singing activation. Everybody will sing and we'll all stimulate the vagus nerve. But do we all feel joy? Don't you feel joy? That's the beauty of it.
Thank you, Renee and David. The downside is I may be too relaxed now to do my job. I'm John Ngai. I'm from the NIH Brain Initiative. I'd like to thank Susan and Ivy for having me be here as the first session provocateur, and of course Diana and her wonderful team for setting this all up. So, why am I here, you might ask? I want to just set up the session to tell you about the amazing things that we can do with greater tools, greater knowledge, greater know-how, greater creativity to understand this amazing thing we call the human brain. Now, this human brain is the most complex organ in our bodies. It is arguably the most powerful computer and most energy-efficient computer on the face of the planet. There are roughly 86 billion, with a B, nerve cells and neurons that, together with about a couple 100 billion non-neuronal cells, that all together make trillions, if not tens or hundreds of trillions of connections that give rise to everything that makes us human, our emotions, our ability to sense not just the outside world, but what goes on in our bodies, to generate behavior and movement, our spirituality, our thoughts, our ability to retrieve memories, but also to see the future. All these things make us uniquely human, but makes each one of us uniquely different from each other. So how does that happen? And one of the key things is that it is such a complex beast that we don't yet have the tools to properly map what's going on, what are the components, to monitor what's going on, but very importantly, to modulate them, which is what happens to us every moment of the day that we're awake, and even when we're asleep, to receive information, to learn, to process, and for here, today's context, to appreciate and to create art. Now, everyone here in this room knows somebody or may be also living with some disorder of the nervous system. It affects 1 in 3 people in our country. There are hundreds, if not thousands, of defined neurologic and neuropsychiatric disorders. And the cost of treating these disorders is immense, not just economically, but of course on a personal and societal level. And these are some of America's, if not the world's, toughest health problems to solve. It is truly a public health crisis. And so I said that we don't yet have the tools to understand this remarkable organ in our body, this remarkable computer. The mission or the goal of the Brain Research through Advancing Innovative Neurotechnologies, or the Brain Initiative, is to create these tools to revolutionize our understanding of the human brain, how it works, not just in health, but also in disease. Because if we don't understand how it works, we'll never be able to fix or cure neurological diseases. The NIH Brain Initiative spans across 10 of the 27 centers of the National Institutes of Health. We're doing things that no one else at the NIH is doing, which is to bring together experts from across many different fields to solve what I think is the hardest problem in biology. It's a partnership between 5 US federal agencies as well as private foundations, and enables the broader community of neuroscientists as well as biotech entrepreneurs. Now, thanks to congressional support, since 2014, we've invested over $3.5 billion into 1,600 projects. So we're really moving the field. So what are we doing that I think is so cool? We are truly driving a technology revolution in the neurosciences. We're creating cell analysis maps of all the cell types in these 86 billion cells. We think there could be upwards of over 5,000 different kinds. What do they look like? How do they connect with each other in these very precise connections? We'll hear about that in a moment, to give us our ability to think and do. We're creating this armamentarium, this big toolkit for accessing these cells so we can better understand how they work and control how they work, ultimately for hopefully treating and curing diseases. And then we're also trying to find better ways of quantifying our behaviors, everything we do, and understand how the processes within our brains drives these processes. So this is a neuroarts forum. Let's look at the beauty of the brain. These are these beautiful cell types identified from folks at the Allen Institute in Seattle, the multitude of cell types. Here's a project that was funded by the intelligence agencies that showed the connections between these neurons or cell types. I think you can see the remarkable beauty of these cells. This is a recent study that from Jeff Lichtman's lab at Harvard, together with Vera and Jane's group at Google Research, that characterize all the cells and connections in 1 cubic millimeter of a human cortex. Okay? 57,000 cells making all these gorgeous connections. How are they generating the computations? How are they responsible for receiving information? And you can zoom in on these different connections. Utterly gorgeous. I hope you're getting some kind of response from this. And zooming all the way in, these are the connections in the little yellow dots between processes from one cell in blue and what they're receiving in green, all the way along the way. So how do these connections change as we learn, as we experience our outside world as well as our inside world? So I just want to leave you today with a few questions we're going to try to address in the first panel. And the first is how and why do these patterns of connections or synapses, how do they change as we experience art as part of our natural world? How do such processes affect our physiological state, the visceral response as it were, and our cognitive state and our emotional state? how has the human brain evolved to both create and behold art? This is really a source of true fascination for myself. And how can we apply this information in an empirical way toward therapies to help people with conditions such as Alzheimer's disease or behavioral conditions such as autism? And with that, I'm going to hand it over to my good friend and colleague, Dr. Rick Huganir.
So why am I here? So I'm in the book. I'm actually in the very beginning of the book because Susan is my wife. So that's another reason. And I might be responsible for part of the very early marriage of arts and sciences. So, but anyway, so I'm here to really talk. I am a neuroscientist. I'm a biochemist. So I look at very basic mechanisms of learning and memory. That's been my interest my whole career. How do we encode memories in our brain? So this is very relevant to how we experience things, how we learn from our experiences during development, during everyday life, but is particularly relevant for aesthetics and art. How does art impact our brains? And so I'm going to give a little primer on brain function, and specifically on plasticity. I'm sure many of you heard about plasticity, and this is really a critical part of how we respond to experience throughout our life. When we're children, right now we're experiencing, taking visual stimulation, sensory stimulation, and all those things are changing our brains, and they change our brains through this process of plasticity. So here, this is my favorite neuron. This is actually a neuron in a dish from my laboratory. And neuroscientists all love neurons. We think they're absolutely gorgeous, and I hope you think they're pretty spectacular too. So as John said, the brain is this remarkable 3-pound squishy thing between our ears. And it contains remarkably 86 billion. I think it's more like 100 billion, but John says it's 86 billion. But anyway, and what's more important is how these neurons work to generate us. And so here is an animation which just shows how these neurons communicate with each other. So these 86 billion neurons are in your brain, and they're forming millions of circuits, connections between each other. So you can think of them as circuits throughout, roadways throughout the brain. And this is just shown here. Each of these neurons contain 10,000 synapses with other connections with other neurons. So we're talking trillions, hundreds of trillions of synapses, synaptic connections in your brain. So here we're looking at a neuron firing. They're firing and connecting with each other. And these are the circuits that underlie everything we do. As John said, they are who we are. They encode our memories. They impact our emotions. They underlie our emotions. They help with our decision making. And so we're zooming in now on the synapse. And this is what my interest has been for over 40 years, is how does a synapse work? And on the left, you can see one neuron coming in and connecting to the second neuron. And so these synapses are really key for brain function and underlie a lot of plasticity and learning and dynamics of the nervous system. So, so here are just a schematic. So there'll be a quiz later. So here we've just blown up. This is a synaptic connection between two neurons, and it's how they talk to each other. So what happens is this, what we call a presynaptic neuron. This is the neuron that's speaking to the second neuron. An electrical signal comes down. It releases chemicals, neurotransmitters. Many of you have heard about neurotransmitters. And the neurotransmitters diffuse across this slight gap between the two cells and activate receptors on the second cell. So this is occurring, think about this, that you have 10 billion nerve cells, you have trillions of synapses. This is happening, right now in your brain. And so, but this is it's not static, right? You learn things. you experience environments, you forget things. And so the brain, these connections have to change. They have to change with your experience. And so there's a process called synaptic plasticity. And so what synaptic plasticity is it regulates the strength of these synaptic connections. And I'll show you this schematically in the next slide. So here, what many of us over the last several decades have figured out is that synaptic plasticity is the strengthening and weakening of synaptic connections to sort of sculpt circuits in your brain. So for example, synapses can get stronger when you experience things and by adding more receptors, so you make a stronger synapse. But they also can get weaker. So if, say, in a simple-minded way, if you forget something, your synapse can get weaker and remove the receptors. So this is a primary mechanism of brain function. It's how we respond to our experiences, to our visual stimuli, and change the brain. Now, what's this got to do with neurosthetics? And so it's key to our memory and our history and what creates our aesthetic sense, but also dynamically regulates our response to art. Now, this is a piece of art that really impacted me. I know exactly where I saw it, when I saw it, where it is right now. Does anybody know where it is? This is not Amsterdam. It's actually Musée d'Orsay. So I know what room it is, what wall it's on, and that's because something in me it struck me, and my history, et cetera, et cetera. So what happened to me when I saw this, it just flooded my brain with a variety of neuromodulators, neurochemicals, and this induced these processes, LTP, or synaptic strengthening and synaptic weakening, and sort of secured and increased my memory of this, created the memory that I still haven't, I've forgotten. This is over 30 years ago that I saw this. So I'll end there, and I'd be happy to talk to anybody afterwards. All these mechanisms we're talking about are really critical in disease and cognitive disorders, autism, Alzheimer's disease, et cetera. And so I work on those as well. So thank you very much. And here's Anjan.
So why am I here? This seems to be the question everybody starts with, and not in a metaphysical sense. But I'm a neurologist and a cognitive neuroscientist, and I direct the Penn Center for Neuroaesthetics. And part of my job here, at least my remit, was to kind of level set for neuroaesthetics in general. So as Susan mentioned, scientists have been slow to come around to this. This is a PubMed search, so you can see the academic literature of neuroaesthetics has really only started in this century. And there was an inflection point about 12 years ago where it's really started to take off and is continuing to take off in a very striking way. One thing is that I'm quite fond of triples and triads. And so there will be a series of these kinds of triads that I'm going to talk about. So the first is, what's the purview of neuroaesthetics? And one thing we use is the way our brain carves out the world into people, places, and things. And so we're interested in the aesthetic experience of people. Why are some people beautiful? What does that even mean? What are the societal implications of that? Places, which can be our relationship to nature, as well as the built environment, which turns out to be quite important, as people during the pandemic really, really started to realize in an explicit way. And things can be consumer products, but we have focused on art. Art presents a fundamental mystery. If you think about why is it that we care about a bunch of paint splattered on a canvas? We don't eat it, we don't have sex with it, and yet we are preoccupied by it. The other way of cross-cutting these ideas is to think, what is the fundamental nature of an aesthetic experience? This is a basic science question. How is it modulated? This is a question about individual differences and cultural differences. And then why does it matter? This is a translational question. Why is this important in our lives? So having said that, I'm going to get to sort of the core framework that we use, which is called the aesthetic triad. And the idea is that there are aesthetic experiences emerge out of this kind of large-scale systems. We've heard a fair amount about the sensory motor systems. We got that terrific introduction from Renee and Dan, which was really activating our sensory motor systems. The emotions, if we're talking about beauty, it's often pleasure and reward. But not only. There are notions, for example, a classic notion of sublime, which introduces a little bit of anxiety in beauty. And aesthetic experiences are nothing if not complex emotional experiences. And then finally, the knowledge semantic system. So kind of alluding to what Rick talked about of how his memory played into his experience of the Van Gogh portrait. But also this introduces notions of how we are different. What is our education? What culture did we grow up in? And how does that change our aesthetic experiences? So once you have this framework, the question, going back to the question, is what is the nature of an aesthetic experience that we can all have? One of the amazing things about evolution, as John mentioned he was interested in, is our capacity for language. Our capacity for language we take for granted, but it's an extraordinary tool. It's an extraordinary tool with which we understand the world. It's an extraordinary tool with which we understand ourselves. And so this is part of a project that we've been doing, trying to establish a taxonomy, a vocabulary of aesthetic experiences. And it is analogous to if you were, for example, sipping a glass of wine. Most people can say, I like it, I don't like it, it's kind of interesting. But if you have a sommelier give you a vocabulary, you start detecting little pieces of your experience and you start enriching your experience. And we think we can do exactly the same thing with art impacts. And so this is a 69-term semantic network that uses fancy statistics called exploratory graph analysis to kind of identify the semantic space of art impacts. From that, we can distill this down into 11 major dimensions. And at the coarsest level, we end up having these 4 things, which is positive affect, negative affect, immersive qualities, and the possibility of transformation. And so with this tool, we've been applying this in a variety of different domains, which I'm happy to talk about as we move along. So I'm almost out of time. I'm going to leave you with one other set of triads, which is we're also talking about architecture. This is a famous architecture by Vitruvius. And one thing about this is the aesthetic part of this triad has largely been ignored in the first part of the 20th century of architecture. What we have found is that architectural experience is also defined by a triad, which we are calling coherence, how legible is a space, fascination, how much are you interested in it, and hominess, the most important one, which is do you feel like you belong in the space? And we find that our brains are responding to these factors, whether we know it or not. And I've gotten the gong. And basically, the last thing I'm going to say, just very briefly, is we have the tools, we have the conceptual framework right now to really push this field, and we have challenges. And the challenges are conceptual, which is we are hampered by this notion that the arts are frivolous, that they are nice to have, but not a need to have. And then the other thing is that we are neither fish nor fowl, which is that if you do science, people know how to fund science. If you do the arts, people know how to fund the arts. But if you're in this liminal space in between, we're stuck. And so I want to thank Diana, Susan, and Ivy for shining a light in this kind of weird liminal space that we find ourselves in.
Hi, I'm Indre Viskontas. I'm a neuroscientist and an opera singer, and I started stage directing operas when I discovered that Michael Nyman had written an opera called The Man Who Mistook His Wife for a Hat, based on the case study by my mentor, Oliver Sacks, who was the inspiration for a lot of the work I did, and I thought there's no one else I'm going to allow to direct this opera if we have the chance to put it on. So I occupy that liminal space, and I think one of the reasons that I'm here today is because I serve as a bridge across these silos. So many of these disciplines have a very long history. We've been making art for as long as we can track our civilization. And so those disciplines are very much evolved, just like scientific disciplines are evolved, just like neuroscience is evolved. And that's why people, even within the domain of neuroscience, are very specialized, and it's hard to bridge these silos. So one of the tools that we have to bridge silos are things like the NeuroArts Blueprint that brings together people across all of these different disciplines in really meaningful ways. And I want to give you another specific example of some of my own work. Today is my first day as the president of the Society for the Neuroscience of Creativity. But I've been part of this organization since its inception about 10 years ago when Anjan's chart showed that exponential rise in research in neuroscience and the arts. And we now have a fair amount of understanding of the neuroscience of creativity, and so we invited educators to come to our conference so that we could show them, look, this is how the creative brain works, this is why you should be teaching it in schools, because we have this 4th grade slump where students start to be less creative in 4th grade when they start to conform. And the educators were very receptive, and they thought this was great, and then at drinks afterwards, they said, but we're never gonna do it. And we said, why not? We just showed you all this great stuff. And they said, because there's no standardized test for creativity measures. It's not going to get my students into college. So my principal isn't going to care, and the parents aren't going to care, and so I don't have time. So that's when we decided it's not enough just to interface with the educators. We need to take that information back to the lab. And for the last few years, we've been developing tools that automatically score creative cognition in students. And we've shown now that not only are those measures almost as predictive as the SAT in terms of GPA and college performance, but they're 15 times less discriminatory. So now, we've actually even now just gotten a $2 million grant across 3 of our labs from the NSF to look at engineering students who are entering into engineering programs. We're testing them on a bunch of creativity measures, and we're going to track them and see which of those measures predict success, so that now we can go back to those educators and say, creativity is going to get you into college, it's going to help your students score high on all of those scores that you need in order to get the funding. Similar work is happening in the sound health space, where again, we have researchers who are doing their work, and then there were therapists who were doing their work, and there wasn't a lot of interplay in between. So we created, along with Renee Fleming's leadership, and Sunil Iyengar, who's here as well, which is funded by the NEA, this network of individuals and organizations and people that are interested in this space. And we've been having convenings and conversations, and that has also led to the generation, as has been mentioned, of the NIH toolkit for music-based intervention. So that field now is also really growing. But there's one more piece that I'm really passionate about that I just want to take 2 minutes, if I still have them, to finish up and talk about, which is we are now at this point where we can talk to the general public about what we're finding in the lab, and that is of critical importance. For too long, either artists or scientists or anyone in between, we spend all of our time creating all of this good stuff and not enough time thinking about how we're going to capture the attention of a generation that is tied to their phones. So one of the passions of mine is to really take this information and make it accessible to the general public. And so from the work of the scientists in the neuroscience of creativity space, we now know that there are these networks that are involved in different parts of the creative process. So for example, these videos, by the way, are made by Omniscient Technology, a company in Australia that maps these beautiful connectomes that really represent these networks that really underlie a lot of our brain states. So the default mode network is responsible for imagination. It's how we generate new ideas. It's really important for the creative process. But so is the executive control network, because that's the set of brain regions that help us get things done, helps us prepare, helps us motivate us and get us to put our goals together strategically. And then once we have a piece of art, evaluate whether it really is good. Unfortunately, these two networks are often in competition with one another. When you're trying to focus, you don't necessarily want to mind wander, but when you're trying to get a new idea, sometimes you're fixated on whatever it is that's right in front of you. So what we've learned across many studies of creatives is that they actually learn to strategically switch between these two networks such that they can use one when they need it and then switch to the other. And how do they do that? With the salience network. And this is where we get the emotions and the motivation and all of these other things that kind of people think of as the gut feeling. And the salience network can serve as a switch, helping you go from one network to another. So we're learning a lot about this, and we now know how to help people apply it. And one demonstration that I recently did was a collaboration with Edwin Outwater and the New World Symphony. And we had, at the end of this first half of our concert, we had an 18-minute piece, Wagner's Prelude and Liebestod from Tristan and Isolde, which, if you don't know this piece, has a very, very, very long time to get to the point, 18 minutes. And then there's a resolution. But of course, there's much more happening along the way. And what we did is we had Edwin's brain with EEG measure that showed the dynamism across these three networks, how quickly he switched from one to the other. But when you saw Edwin, the conductor, going into the default mode network, that gave the audience permission to also let their mind wander and let some of those other ideas trickle in. We had a cellist on stage, and very quickly, the dynamics of her brain across these three networks synchronized to Edwin's. And then we had one on me, and I was representing the listener in the audience. And while I let my mind wander, just for effect, for a good 8 minutes, before mine too synchronized with the others. And so the audience came away with this understanding, this impression of these three networks and how they synchronize and how they relate to the artistic experience. I'm done. Yes.
Thank you.
Hold it close.
Okay, great. Thank you. That was, all of you, amazing. When initially I thought I was going to ask Anjan about this, how did we evolve the ability, or how did we take leverage or use our evolutionary evolved brains to both create and behold art. But Indre, you showed this amazing demonstration. Could you two talk about this a little bit? Because what's going on there from the different creators and the beholder?
I mean, I think that this is something that we can't separate a time when humans weren't making art. I don't know of any evidence that there was a time when we weren't somehow engaged in some kind of art making, even if it's sitting around the fire, which we discovered 1 million years before we discovered language, or before language evolved, and just exchanging, kind of primitive calls or body signals, et cetera. So to me, those two are intertwined, and I think the question is, how do we harness this evolutionary history now and allow for this expression that I think for too long has been relegated to, as you mentioned, a nice to have, and why isn't it sort of a central understanding that this is a super stimulus, just like, so many of the other ways in which we study the sensory systems by looking at the extremes. in some ways, art is the extreme in a lot of these foundational networks of how the brain works.
Do you want me to add to that?
Yes.
So it is true that we've had a decorative impulse as far back as we can trace. So musical instruments from 80,000 years ago, there are beads from 100,000 years ago, there are etchings in the Blumbus caves in South Africa that also go back 80, 90,000 years ago. And so it does seem as though there's a fundamental desire to decorate that goes beyond the function of objects. And I think that most people believe. I have argued that art, the way we think about it, is not a natural kind, in the sense that art is too many different things, and we have a particular conception of that comes from 17th and 18th century Europe of what art is. And some of our work is trying to deconstruct that, so that if you go listen to a fantastic chamber orchestra, this somehow is art, but if you go to your church and listen to the choir, this is not art. So there's a way in which some of these categories don't really make sense. And the other thing that we know is that people tend to be quite consistent in their preferences for natural kinds, like faces and natural landscapes, and quite varied in their preferences for art and architecture. And so what's the source of that variance is something we're interested in. Now, getting back to John's question of what's the relationship between creativity, which is the output side, and aesthetics, which is the input side, it's almost as though the processes are in reverse, which is when people are being creative, as Indre mentioned, there's this kind of expansive exploratory phase in which the default mode network, we think, is involved. And in the perception of art, if one knows or is used to or is trained to look at art, that's where you want to end up, which is you're looking at art and then it throws you back into yourself, into your imagination, and allows you to expand how you're thinking. And so there's a kind of a reverse sequence in an idealized form of what creative people are doing and what people who are appreciating those creative outputs are doing.
Yeah, so I want to come back to this in a moment, but I want to ask Rick a question. When you showed this painting that you saw in the Musée d'Orsay, you can remember probably to infinite detail about where you were, what was going on around you as you took in this painting that clearly had some huge emotional impact on you. Now, there's been an observation in neuroscience and neuropsychology that when we are having an experience with what we call high emotional valence, either of a joyous event or a deeply traumatic one, the memories tend to become solidified to a much greater degree. So this apparently happened to you. I mean, how would you think about it in those terms, in terms of your experience that day 30 years ago?
Yeah, I mean, we actually know a lot about this at the basic science level, and so, we all remember, certain events. 9/11 is one, of course. For those of you who remember, read the book, My First Kiss with Susan is in the book, and
you can stop there.
And memorable events, and so we know a lot about this actually from studying animals. That when these are mostly due to neuromodulators, so many of you have heard of dopamine, norepinephrine, and a variety of other drugs and neuropeptides, and these are floating around in our brain all the time. And so you're in a certain body state when, which can be activated by experience. And so, a lot of those neuromodulators enhance memory formation. And so I know what happened when I kissed Susan, but
You forgot your other girlfriend.
yeah, no, that's a different story.
It's called extinction. It's called extinction, yeah.
But, why that painting impacted me so much, I don't know, And well, it's an intense painting and beautiful to me. But I think it's if I don't know the answer, but it's part of my history, my bringing up, my memories, and how I was, raised, and also knowing something about him and knowing the pain and his creativity, and that those portraits, all the portraits, including the one in the Van Gogh Museum in Amsterdam, which we're going to next week actually, are just absolutely amazing. You see his intensity, his pain, and so I think that's what impacted me emotionally, and that's seared that memory into my brain.
Yeah, I had a somewhat similar event. Now that I'm recalling from your recollection, it was over 40 years ago. I was standing in front of Aspens by Ansel Adams, and the breath left me. And I can see the walls, I can see the corner of the gallery as I was looking at this. So it's true, these emotional events, they impact us, but there's kind of a bidirectionality to that, yeah? So the issue of art and architecture, which another term that we use is built environment. It's humans' creation of an environment that is not directly from the natural world. And Anjan, what's kind of really quite curious to me is how different cultures both create and respond to art, but not just different, there's different cultures we can think about, Eurocentric cultures versus cultures from Asia, but also within our cultures. If you look at America, the United States of America, we have so many different cultures. We just listen to the music that people are playing or listening to as we just walk down the street here, down Broadway. It's so different. So there must be some, well, I guess part of that is the hard wiring of us, but what really gives rise to these experiences, these changes that Rick studies at the synaptic level? And if you look at architecture, that built environment that quote unquote works or doesn't work, is there some secret sauce that architects aren't telling us about? Are they intuiting what works? What makes people feel safe or creative in an environment that allows them to express their own creativity? Do we know anything about that?
I have opinions, but
that's good enough. That's good enough.
I'm reluctant to make broad statements about what architects should do or shouldn't do. But there are a couple of points I'd like to make, which is sometimes when I give talks on architecture, I start out with the idea that we are an old brain trapped in a new environment. And what I mean by that is that our brains evolved during the Pleistocene, about 1.8 million years ago, or 1.8 million years in span, in which we lived out in nature. And it's only in the last 8 to 10,000 years we've been in cities. It's only in the last little bit we've been in cities like Manhattan, right? Very, very different than being out in the savannah. And so how do we contend with that? Our brains are still stuck in the past, and we are stuck in the present. And so one question is, what is our relationship to nature? And to answer your question, one of the things we find with our the triad for architecture, is that those get abstracted away from the specifics of an individual environment, which is the space coherent? It doesn't matter what kind of architecture, right? That's a question. Is it legible? Do I know where I need to go? Where's the bathroom? Where's the, that kind of our ease with which we navigate. Fascination is a question. Is it interesting? Do we want to explore it? And it turns out that there are individual differences. What neurotypical people find fascinating, people on the autism spectrum find repulsive. They move away. It's almost as though it's information overload. And hominess, I think, as I mentioned, is the most interesting one, which our own baggage, our own backgrounds matter. So if you grew up in the desert, if you grew up in the Arctic, if you grew up in a crowded area, if you grew up in the wilderness, all of that will matter for what people feel comfortable with. But these, I think, the principles are probably generalizable across cultures.
I just want to jump in, though, and to that point, say that one of the big environmental influences is other people. The social context, and that's actually really been pretty well studied by Teresa Amabile at Harvard and Ronnie Ryder-Pullman in Nebraska, and showing that there are specific things that managers can do to kill creativity, if that's what they want to do, which of course they say they don't, but they do it anyway. And then there are specific social constructs, so social environments, and how we reward creatives, whether we reward them, or we tell them they're creating for a reward, versus giving them a reward after they've done the creating, makes a huge difference on how creative their output is.
Yeah, we're seeing some really cool studies now, and as you allude to, where we can actually we now have the tools to monitor brain activity to certain regions in both humans as well as non-human models, not just of an individual that's being shown some scene or being given some artificial experimental stimulus, but interacting socially with another member of the species or with some other species. So it's really fascinating. So Indre, you mentioned there was one of the many things you showed, but one really struck me was this little connection diagram from researcher to educator back to researcher, and it kind of jingled something in my memory about something we refer to as reverse translation. So a lot of times we think about, I'm going to learn something here, and I'm going to translate it to some other benefit. And in the biomedical sciences, there's a basic discovery that Rick makes, translating that to some hopeful therapy because he learned something about mechanism. But what we often overlook is the reverse. What can we learn about the basic processes through actually interacting with these humans, or what we learn from that applied approach? Can you talk a bit about that?
Yeah, that's exactly right, and this is why we need to, as scientists, both include artists in work about art, and it sounds silly, but respect them as intellectual equals. I think a lot of the times, because we don't have the same vocabulary, we assume we know more about that field than we actually do. And to sort of really spend some time dialoguing and understanding what are the complexities, what is the evolution in that field, that can only happen if you actually take the time and you respect the collaborator that you're working with. And I know there are, like the Renee Fleming Investigator Award grants through the NeuroArts Blueprint, there are a number of initiatives now that are really trying to tackle this problem of bringing the artist in as a partner and bridging that kind of vocabulary, knowledge, and respect divide.
Great.
So I'm going to put you all on the spot right now to conclude this panel, and I'm going to ask each of you, what is your ask to this community in less than 1 minute each?
You've all been provoked. Let's continue the conversation during this day, based on science, based on evidence, but based on creativity and how we think about these enormously interesting and complex problems.
So I think science is ready for this. I think science is ready to engage this. I think all universities and what I've heard from Susan going around the world, all over the world, including Johns Hopkins. We had an event the other night where Susan gave a lecture. And all the leadership from all the schools at Hopkins were there, and they all came up to her afterwards, and they're all in. So they're creating all these art, immersive things in their schools, in in the hospitals, etc. So I think it's timely. I mean, I think post-COVID, it's really just made us realize we need more. So keep doing the good work. And I'll be along with you.
So every week I get about at least 3 emails from students around the world, young people around the world, saying, I'm interested in this, how can I get involved? Can you read this? Can we chat? And I don't have the bandwidth to do this. That's all I would be doing. But the point is that there is so much interest from young people and not enough interest from old people. And my ask is where I ended my talk, which is that we're neither fish nor fowl, and people know how to fund fish, people know how to fund fowl, and we are stuck in the middle.
So a wise person told me that if you want money, ask for advice. So I would like to ask for some advice for how we creativity neuroscientists can help you in your organizations. What do you want to know from the field of the neuroscience of creativity and the arts more broadly?
Thank you.